Just like we saw that the slope can be found either algebraically from the formula or by using a graph, we can also find the y-intercept of a line either algebraically or by using a graph. In our first example, we're going to find it both ways. We're looking for the equation of a line that has a slope of negative 2/3 and a point 6, 1. We already know the m value, but we don't know b because that's not the y-intercept. It's not where the graph crosses the y-axis. So we really need to find the value of b in order to write our equation y equals mx plus b. Algebraically, I'm going to start out with that equation, y equals mx plus b, and I'm going to substitute all the values that I know. I definitely know m always, negative 2/3 for this problem. And I also know a particular point on the line, which give me numbers that I can substitute in for x and y. So let's put those in. Y is 1, m is negative 2/3, multiplied by x, which is 6. And that only leaves one unknown, b, in my equation, which I should be able to solve for. Negative 2/3 times 6, negative 12 divided by 3 would be negative 4, plus b. And by the way, just a reminder, you can certainly do fraction arithmetic on your calculator if that's not a strong point for you. If I add the 4 to both sides, I get a value of 5 for b. So I know m, I now know b. I can write the equation of my line as y equals mx plus b, or y equals negative 2/3 x plus that 5 that we just figured out. Notice that when you write the final equation of the line, we don't put in the values 6 and 1 for x and y. Those just belong to one particular point on the line. This equation now refers to all of the points on the line for any x and y that fit the equation. Let's take a look at the same problem graphically. Graphically, I always need a point to start, so I need to graph a point on the line first. And in this particular case, we knew that the point 6, 1 was on the line. So I'm going to go ahead and plot that point right away. I then was told that the slope m is negative 2/3. And I'm going to use the graphical concept of slope as rise over run to draw this equation, or to draw this line rather. I want to say a word about the negative sign. A slope of negative 2/3 can either be negative 2 over 3 or 2 over negative 3. It doesn't matter which way you think of it. You're going to get the same line in the long run either way. I'm going to start, at least, by thinking of this as negative 2 over positive 3. And so from the point that I knew, 6, 1, I'm going to say my rise is negative 2, and my run is positive 3. So I'm going to go down 2, and then to the right 3. And that gives me another point on the line. Now I could continue to do this, but I'm going to kind of run out of the graph paper, at least the size that I gave you. So let's do another point, but let's get another point in the other direction. If I think of the rise as positive 2, and this time put the negative on the bottom with a 3, that means I'm going to end up going up 2 for my rise, and then left 3 for my run. Let's do that one. I'm going to go back to my original point again. And this time rise is up 2, and run would go to the left 3. Gives me another point on the line. Now I can continue to do this as long as I like, or I can simply take a nice straight edge and draw my line. Okay. I'm actually going to go ahead and do rise and run one more time because it looks to me like I'm probably going to hit the y-axis, and I might as well be sure that I'm being really accurate. So let's do that. Let's once again go up 2 and to the left 3. And we can see that actually gets us right exactly to the 5 on the y-axis and shows us our y-intercept. I'm going to draw the line just by connecting those points. All right, so we've got our b value, 5. And once again, we can write the final equation of the line. Y equals mx plus b, as y equals negative 2/3 for the m times x plus that b value of 5, giving us exactly the same answer from the geometry or the graph of the problem as we got algebraically, which of course better happen so that our math works out right. We're going to do a couple more examples where we're going to kind of contrast looking at an algebraic solution and a graphical solution to the same problem. Again, always hopefully seeing that we get the same answer. This time, instead of giving us a slope and a point, we're starting out with 2 points, 2, -1, and 5, 7. We'll begin then by saying anytime we need the equation of a line, y equals mx plus b, we always have to find a slope m and a y-intercept b. So I'm going to start out finding m. Algebraically, since I was given 2 points, it seems reasonable this time to use our slope formula, y2 minus y1 over x2 minus x1. And I'll just refer to this as the x1 and the y1, and this is the x2 and the y2. So I would have 7 subtract -1, and on the bottom, 5 subtract 2, gives me a slope of 8/3. All right, next I need to find b, and I'm going to do this exactly the same way as I did in the last example. For our equation of our line, y equals mx plus b, I'd like to substitute in numbers for everything except for the b that I'm trying to find. We already know m, we just found it here. And then I have a couple of choices for x and y. I could either use the 2 and the -1, or the 5 and the 7. I tend to make less mistakes with positive numbers, so I think I'm going to use the 5 and the 7 this time as my x and my y. Let's plug all those values into our equation. Y is 7, m is 8/3, multiplied by the x value 5, plus b, which we don't know yet. See, 8 times 5 would be 40 over 3, plus b. And then to get b, I'm going to have to subtract the 40/3 from both sides. And that's some fraction arithmetic that maybe it's not convenient to do in my head. So let me just remind you real quickly how you can do that on a calculator and get a nice fraction, not decimal, for an answer. I'm going to take 7 minus 40/3. So I have my TI-84 here, and I'm going to start by just typing it in that way. 7 minus 40/3. And it gives me an answer, but it gives to me in a decimal form. If I were going to write that down, I would have to round off that decimal, And when we don't have to round, it's nice to give exact answers. Your calculator will convert to that fractional form for you. It's down here in your Math menu. And the very first option, notice, has that little triangle. That means change to a fraction. So I'm just going to hit Enter to select that. It's going to take my previous answer and change it to its fractional form, negative 19/3. So we now know M, we know B. We can write the equation of the line. Y equals mx plus b, or y equals 8/3 x minus 19/3. All right, let's go ahead and graph this line and see what we can get. Our 2 points, I'm just going to repeat them down here so I have them when I move my paper, is 2, -1, and then also 5, 7. Those are both on our line. So let's see, I've got 2, -1 would be down here, and then 5, 7 would be up there. Now I can certainly use, again, a straight edge and draw a straight line through there. But let's go ahead and reminding ourselves that the slope was 8/3. Let's see if we can use that to accurately draw at least one more point. My problem right now is that if I were to think of this as a rise of up 8 and to the right 3, I don't have enough space on this particular piece of graph paper to go up 8. So here's a little trick for you. If I think of both the numerator and the denominator as negative, negative divided by negative is still a positive slope, but I can now think of my rise as down 8. And then I have to think of the run as left 3. That's going to fit better on my graph paper, so I'm going to use that one. And starting from here, I'm going to go down 8 here, and then to the left 3. 1, 2, 3. Unlike the last problem, I didn't happen to very nicely hit a good integer point on the y-axis, but I can still draw my picture. There's my line. Now, I can easily draw the line because I was given 2 points. Using the slope, I can even predict where more points are going to lie. But notice, it's not real easy to predict the exact equation of the line based on this graph, because the point where I cross the y-axis here is actually between -6 and -7. It's not a nice integer value, and therefore I can't just look at that graph and say, oh yeah, I know what b is. For that reason, graphing the line is possible, but finding the equation of the line is not such a good idea using just the graph in this particular case. You would want to go ahead and use the algebraic method instead. All right, our last example for this section, I want to take a look at one equation where we aren't given our original line in a y equals mx plus b form. We look at this and we can identify it as probably a linear equation. I'm noticing that both x and y are to the first power. There's no square roots or fractions or anything like that, so it's probably a linear equation. It's just not in that y equals mx plus b form yet. We're going to start by getting that format, and that's really what I mean by saying write that linear equation as a linear function. So let's go ahead and begin with what we were given. And since our slope-intercept form has y by itself, y equals mx plus b, I'd like to try to solve this equation for y, get y by itself. I'm going to begin by subtracting the x on both sides. So I have negative 5y equals the opposite of x plus 15. And then I have to divide both sides by negative 5. Be a little bit careful. This is an easy place to make a mistake. The left-hand side, of course, is now just y. But on the right-hand side, that negative 5 does have to divide both terms. I'm going to write this one out just so you can see it. Negative 5 divides both the negative x and the 15. Here's another little tip for you. Certainly negative divided by negative makes that a positive slope. But if I want to write it in a way that emphasizes the value of m, rather than just write this as x over 5, I might want to write it as 1/5 times x. That makes me really be able to see that that m is 1/5. And then 15 divided by negative 5 is negative 3. And there's my b value, negative 3. So m is 1/5, and b is negative 3. We can use that information to fairly easily graph our line. I'm going to start with my b value, negative 3, the y-intercept right here. And then the slope of positive 1/5, if I think of that as the rise over the run, I can go up 1 and to the right 5, giving me another point right here. I could actually do that again, up 1 and to the right 5, putting me right there. And I do have 3 points. That's more than enough to graph the line. You could have also gone down and to the left to get more points, but I'm just going to go ahead and connect the dots here and sketch the equation of my line, or sketch the graph of my line, rather, like so. All right, so we can certainly go from an equation to a graph. The last example has us going the other way, from the graph to the equation. And in this case, we're given this picture, and we want to know, what line is that? What's this equation? As always, we need to find m and find b. Anytime we want the equation of a line, we need to know those two things. And to get m, we are just going to read it off the graph. We'll use the rise over run definition of slope. And again, just remember, you want to make sure you're getting 2 nice points that you're absolutely sure go through integer values. And as I'm looking at this, I'm thinking this point right here, which happens to also be the y-intercept, which we'll use a little bit later. But it's a real nice point. Goes through 0, 7. And then I'm coming down over here, and it looks to me like 4, 4 is also definitely right on. Notice there's a couple others that seem to come close to those little corners of the squares, but they're not quite there. You want to be right on. So I'm going to go with the 4, 4 here as my other point. And then thinking rise over run, I had to go down 3. So there's the rise. And then I had to go over 1, 2, 3, 4. So there's the run. And so my slope is simply negative 3/4. The b value is actually this one that I started with, the y-intercept here. And that was 7. So the equation of the line y equals mx plus b is going to look like y is equal to negative 3/4 x plus 7. This is the end of section P1. And in the next video, we'll begin section 2 of our preview chapter.